Bismillah ar-Rahman ar-Rahim. In the name of Allah, most gracious, most merciful. تكون محاضراتنا في موضوع Automotive Starting Systems and Motor Designs. This is the lecture for about subject Automobile, Electrical and Electronics. Now we come to explain about gear reduction starters and positive engagement starters. These two types for starters. The first type, gear reduction starters. Some manufacturers use a gear reduction starters to provide increased torque. يستخدم مجموعة مسننات أو تسمى أحيانا بشادي لزيادة العزم المزود من قبل الجير ريدكشن ستارتر من قبل مبادئ الحركة للمكائن والآلات الذي يسمى سيلف ستارتر أو السيف باللهجة الدارجة. The gear reduction starters differs from most other designs in that the armature does not drive the pinion gear directly أي يحرك البنيون مباشرة في التصميم وإنما عن طريق مجموعة مسننات كما سيأتي وستكون هناك نسبة بينهما كما سوف نشرح. The armature drives a small gear that is in constant mesh with a larger gear depending on the application. The ratio between the two gears is between 2:1 and 3.5:1. هذه النسب التي تحدثت عنها. The additional reduction allows for a small motor to turn at higher speed and greater torque with less current draw. The solenoid operation is similar to that of the solenoid shifted direct drive starter in that the solenoid moves the plunger which engages the starter drive. يعني يشابه من النوع الأول التقليدي الذي هو عبارة عن كومباكت السولونويد مع الدرايف. هنا أيضا يتشابه معه يحرك بلانجر يعني تحرك الأوفر رانينج كلتش التي تؤدي إلى تعشيق البنيون كير مع الفلاي ويل. نأتي إلى النوع الثاني the positive engagement starters. Positive engagement starters commonly used starter on Ford applications in the past was the positive engagement starters use the shunt coil windings of the starter motor to engage the starter drive. The high starting current is controlled by a starter solenoid mounted close to the bottom. When the solenoid contacts are closed, current flows through a drive coil. The drive coil creates an electromagnetic field that attracts a movable pull shoe. The movable pull shoe is attached to the starter drive through a plunger lever. When the movable pull shoe moves, the drive gear engages the engine flywheel. As soon as the starter drive pinion gear contacts the ring gear, the contact arm on the pull shoe opens a set of normally closed grounding contacts. With the return to ground circuit opened, all the starter current flows through the remaining three field coils and through the brushes to the armature. The starter motor then began to rotate. To prevent the starter drive from disengaging from the ring gear if partly voltage drops while tracking, the movable pull shoe is held down by a holding coil. The holding coil is a smaller coil inside the main drive coil and it's strong enough to hold the starter pinion gear engaged. Permanent magnet starters, other type of starters drive the permanent magnet starters. Gear reduction (PMG) in short term. This PMG starter design provides for less weight, simpler construction, and less heat generation as compared to conventional field coil starters. يعني تتميز بهذه الميزات مقارنة مع conventional field coil starters مع الستارتر التقليدي اللي هو الأول الذي هو compact. فإنها simpler construction, less heat generation and less weight. فيها هذه الميزات الثلاث. The permanent magnet gear reduction starter uses 4 or 6 permanent magnet field assemblies in place of field coils. Because there are no field coils, current is delivered directly to the armature through the commutator and the brushes. The permanent magnet starter also uses gear reduction through a planetary gear shift. The planetary gear train transmits power between the armature and the pinion shaft. This allows the armature to rotate at a greater speed and increase torque, as we see in the right picture. The planetary gear assembly consists of the sun gear on the end of the armature and the three planetary carrier gears inside a ring gear. The ring gear is held stationary when the armature is rotated. The sun gear causes the carrier gears to rotate above the internal tip of the ring gear. The planetary carrier is attached to the output shaft. The gear reduction provided for by this gear arrangement is 4.5 to 1. By providing for this additional gear reduction, the demand for high current is lessened. يعني لأنه توجد عبارة عن تقليل للنسب من 4.5 to 1 وهذا ترتيب الجير arrangement يؤدي إلى تقليل الحاجة إلى current أضافي إلى تيار أضافي. AC motor principles. A few years ago, the automotive technician did not need to be concerned much about the operating principles of the AC motor with the increased focus on hybrid electrical vehicles and electrical vehicles. This is no longer an option since most of these vehicles use AC motor. AC voltage has a changing direction of current flow, as we see in the right picture. Like the DC motor, the AC motor uses a stator, field winding, and a rotor. Common types of AC motors are the synchronous motor and the induction motor. هناك نوعين AC motors, synchronous motors and the induction motor. In both motor types, the stator comprises individual electromagnets that are either electrically connected to each other or connected in groups. The difference is in the rotor designs. الاختلاف بينهما بتصميم الجزء المتحرك الروتر. AC motors can use either single phase or three phase AC current. There are three factors that cause the magnetic field to rotate. The first is the fact that the voltages in three-phase systems are 120 degrees out of the phase with each other. يعني الزاوية التي بين كل فيس بينهما هي 120 درجة بالنسبة لثلاثي الأطوار ومحرك ثلاثي الأطوار. The second is the fact that the three voltages change polarity at regular intervals. Finally, the third factor is the arrangement of the stator windings around the inside of the motor. Synchronous and induction motor. We talked about two types of these AC motors: synchronous AC motors and induction motors. Synchronous motor, the speed at which the magnetic field rotates is called the synchronous speed. We know the synchronous speed equals 120 multiplied by frequency divided by pulse. يعني 120 مضروبة في التردد ومقسمة على عدد الأقطاب. هذه درسوها في المرحلة الأولى أو الثانية تدرس في كليات الهندسة. The two main factors determining the synchronous speed of the rotating magnetic fields are the number of stator poles per phase and the frequency of the applied voltage. A synchronous motor operates at a constant speed, regardless of load. The speed of the rotor is equal to the synchronous speed. The synchronous motor does not depend on induced current in the rotor to produce torque. The strength of the magnetic field determines the torque output of the rotor, while the speed of the rotor is determined by the frequency of the AC input to the stator. An induction motor وهو النوع الثاني generates its own rotor current يولد بنفسه تيار الروتر الجزء المتحرك by induced voltage واسطة الفولتية المحتكة from the rotating magnetic field of the stator. The current is induced in the windings of the rotor as it cuts through the magnetic flux lines of the rotating stator field. Generally, the rotor windings are in the form of a squirrel cage. However, wound rotor motors are constructed by winding three separate coils on the rotor 120 degrees apart. The rotor will contain as many rolls per phase as the stator winding. These coils are connected to three slip rings located on the rotor shaft, so rushes can provide an external connection to the rotor. The difference between the synchronous speed and actual rotor speed is called the slip. Slip is directly proportional to the load on the motor. When loads are on the rotor's shaft, the rotor tends to slow and the slip increases. The slip then induces more current in the rotor and the rotor turns with more torque, but at a slower speed and therefore produces less CEMF, which means this in short term, which means counter electromagnetic force in hybrid electrical vehicles and electrical vehicles. The direction of motor rotation will need to change to meet certain operating requirements. In a three-phase AC motor, the direction of rotation can be changed by simply reversing any two of its stator leads. This causes the direction of the rotating magnetic field to reverse. Now we come to explain integrated starter generator. What is the integrated starter generator? It is one of the newest technologies to emerge as the integrated starter generator. أحد التكنولوجيات الحديثة وهو ال ISG كمختصر للintegrated starter generator. Although this system can be used in conventional engine powered vehicles, one of the key contributors to the hybrid fuel efficiency is its ability to automatically stop and restart the engine. إحدى قدراتها هي الإيقاف الأوتوماتيكي وتحريك الماكينة أيضا الأوتوماتيكي under different operating conditions تحت ظروف مختلفة. A typical hybrid vehicle uses a 14 kilowatt ونعرف أن السيارات الحجرية تحتاج عمليا إلى 14 كيلووات. Electrical induction motor or ISG between the engine and the transmission ويوضع ال ISG بين الماكينة والترانسميشن. The ISG performs many functions يؤدي وظائف عديدة perform many functions such as fast, quiet starting, automatic engine stop starts, to conserve fuel, recharge the vehicle batteries, smooth the driveline surge, and provide regenerative braking. The ISG is a three-phase AC motor. At low vehicle speeds, the ISG provides power and torque to the vehicle. It also supports the engine. كذلك يدعم الماكينة. كيف يدعم الماكينة؟ في When the driver demands more power during vehicle deceleration, ISG regenerates the power that is used to charge the traction batteries. The ISG can also convert kinetic energy from AC to DC voltage. When the vehicle is traveling downhill يعني عندما تتحرك الآلة أو السيارة بمنحدر and there is zero load ولا يوجد حمل صفر load on the engine, the wheels can transfer energy. طبعا العجلات سوف تنقل الطاقة إلى transmission وبعد ذلك إلى الماكينة عن طريق ال ISG اللي هو Integrated Starter Generator. هذه إحدى فوائد ال Integrated Starter Generators. The ISG then sends this energy to hybrid vehicle battery for storage وبعد ذلك تنتقل الطاقة هذه التي انتقلت من العجلات تنتقل إلى الترانسميشن ثم إلى الماكينة عن طريق ال ISG ثم إلى البطارية لخزن تلك الطاقة. An ISG can be mounted externally to the engine and connected to the crankshaft with a drive belt. This design is called a belt alternator starter bus يعني الذي يستخدم الحزام المتحرك أو الشريط الناقل للحركة وكما هو واضح في الصورة يعني هذا البولي يستخدم لنقل الطاقة عن طريق حزام النقل أو عن طريق شريط الذي يتحرك على هذا البولي. In these applications, the unit can function as the engine's starter motor as well as a generator driven by the engine. Both the bus and the ISG use the same principle to start the engine. Current flows through the stator windings. It generates magnetic field. It generates magnetic fields in the rotor. This will cause the rotor to turn وهذا يسبب تحريك الجزء المتحرك thus turning the crankshaft and starting the engine وبالتالي يؤدي إلى تحريك الكرانكشافت الذي يحرك الماكينة. In addition, this same principle is used to assist the engine as needed when the engine is running. Thanks for attention. Any question you can text me.